Number 68, integrated concepts. If you want to cook water at 150 degrees Celsius, you need a pressure cooker that can withstand the necessary pressure. Letter A. What pressure is required for the boiling point of water to be this high? All right, so remember the relationship between absolute pressure, vapor pressure, and then boiling point. Okay? If we want, so take a look at this table over here on the left-hand side. So if I want water to boil at 150 degrees Celsius, okay, take a look at the temperature there. That means that the absolute pressure must equal the vapor pressure. And they told us what the vapor pressure of water is at that temperature. So to boil at, and basically that's what it means to cook at, okay? To boil at 150 degrees Celsius, I'll say the absolute pressure must be 4.76 times 10 to the 5th Pascal. Okay, because the absolute pressure must equal that vapor pressure in order for the water to boil. All right, so that takes care of letter A. I mean, this is letter A. That's all letter A is. Just understanding the concept, the connection between vapor pressure, absolute pressure, and then the boiling point. So letter B now, it says, if the lid of the pressure cooker is a disc of 25 centimeters in diameter, what force must it be able to withstand, right? So the disc is now going to be 25 centimeters. So let's just create a little pressure cooker here. All right. And actually, let me do the top here. So here's your pressure cooker. All right. And the top, they said, is a disc. And that the diameter they mentioned was 25 centimeters. Now, we probably need this in terms of the radius, right? The diameter is going to be about 25.0 centimeters. We know that if we can, well, let me just convert that. Let me just find the radius from that because it's easier. It's about 12.5 than centimeters, right? We just have to divide it. And then we have to convert the centimeters into meters. So you just have to divide out 100 from here or move the decimal 2 places to the left. 0.125 meters. So this is the radius, all right? Now, we know inside of this container, okay? Now here's the critical insight to the problem. This is the absolute pressure in which water will boil, okay? But what I need to do is I need to find the gauge pressure, aka the pressure inside of this container, the excess amount of pressure over atmospheric pressure. All right, so if I find that now, gauge pressure will be equal to the absolute pressure minus then the atmospheric, 1.013 times 10 to the 5th. We then simply plug in now the absolute pressure of 4.76 times 10 to the 5th minus then 1.013 times 10 to the 5th. And what do we get? So we take out the calculator, 4.76 times 10 to the 5th minus then 1.013 times 10 to the 5th. And we get a value of about 3.75 or so, right? 3.75 times 10 raised to the 5th Pascal. Now this is the pressure, right? This is basically the resultant pressure, more or less, that is going to be pushing up on this lid, okay? It's in excess of the atmospheric pressure, okay? Now that being the case, we now are able to solve then for the force. Why is that the case? Well, remember, the basic force equation is the basic pressure equation. If pressure will be equal to the force applied divided by the area over which that force is applied. So this is the pressure, and this pressure is being attributed to every part of the internal surface area, okay? So the area over this now, that area is experiencing a net 3.75 times 10 to the 5 pascals of pressure. In other words, 375,000 pascals, all right, is the net or resultant pressure pointing up, right? Because it's in excess of then the atmospheric pressure pushing down. That's what this formula just solved for. Now that we know that, we can take the gauge pressure here of 3.75 times 10 to the 5th equals then the force divided by the area. Well, the area is a disk, so that sounds to me like a circle, right? It has to be perfectly circular. right? It might be an ellipse. I don't know, but I don't, what's the formula for the ellipse then? It depends on the eccentricity. So we have pi then multiplied by r squared. That's why I needed the radius over here. So let's just get rid of the r, square, the variable, and plug in the value, 0.125. Square that. Now all we need to do then here is find that force. So it's a cross multiplication. So you take the 3.75 times 10 to the 5, multiply it by pi, multiply it by then 0.125 squared. And what do we have? So the force then exerted is going to be about 1.84 times 10 raised to the 4th newtons. Okay? So that's the force now that the lid has to overcome so that it doesn't blow off. Okay? And then you could convert that into how many, kilograms that might be or something. If you took that and divided it by 9.8, that's about 2,000 kilograms. I mean, it's actually a quite high pressure. Okay, so those things have to be quite strong. Okay. Anyway, thank you guys for tuning in. Hopefully this helps. Please remember to help us out and subscribe, and we'll see you next time. Take care.